You're listening to Wurth Elektronik's What's Up Radio podcast, where each week we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Wurth Elektronik specialists who will shine a light on some interesting topics, like energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Wurth Elektronik's What's Up podcast. And welcome back to part 2 of our 2-part series with our panel of experts, including Anas and Stein from Nexperia, as well as Jared, Amir, and Shireen from Wurth Elektronik. I'm your host, Amelia Thompson, and in part 1, we explored the history and the unboxing of the NEVB-MTR1-C-1 motor driver evaluation kit with Nexperia. So in this episode, we're digging into the technical details. We're going to highlight unique features as well as various applications and also discuss open source capabilities. You also mentioned earlier the hackability of it. Can you explain what you mean by that?
Yeah, so there are multiple levels, right? So we kind of define this board in multiple levels. So when we say ease of use, that is essentially getting yourself up and running, getting the motor spinning, right? Then you have another level, that is where you connect your own power supply, you connect your own motor, right? And you start doing your own testing. However, very rarely that actually, and obviously swapping out certain devices with some other devices is what you want. But rarely that doesn't necessarily show your application. So whatever your application means or is, that's not necessarily what it is. So our board, we've kind of built it in a way where you can everything from bypass certain areas to easily swap in and out components, to try out different drive methodologies, to connecting different microcontrollers, because it's very difficult for us to know what microcontroller you are going to use. All those different things, they start coming into play. Now, if I was a listener to this, I would immediately say, oh, well, that sounds absolutely horrible because I have a lot to learn about this board. And I would agree. And that is why Anas has been tasked with the critical task of documenting all the areas that we can foresee where you want to break it out, simplify, and whatever. So to be fully clear, our design files, they are also open source. So they're under MITx licenses, both are design files and code. And we also have a user manual, which is 60, Anas, maybe correct me, 60, 70 pages long. Last time I saw it, ever growing, essentially. But it's not meant to be read back to back. Unless that's really your thing, we're not going to stop you. But there is the quick start or get yourself quickly set up section. And then the rest is essentially a reference, right? So if you really want to dig deeper into the gate drivers, so we have Nexperia gate drivers on there. If you really want to dig deep into the gate driver operation, we have documented everything in terms of what's surrounding it, why is it surrounding it, all the good stuff. If you want to dive into the MOSFET side, obviously the MOSFET side is the most interesting thing, being from the MOSFET division of the Nexperia. Yeah, obviously, exactly. We also have documented that. So in those environments, or from our experience where we had an evaluation board, we wanted to change something and you can't do it because you don't fully understand what's the implications of changing it or why changing this resistor breaks half the board. We've tried to make it such that you can always just read your way and figure your way out. Down to the level of, Anas, if you actually show the board and flip it the other way around, it is essentially self-documenting, or quote-unquote self-documenting. So we've put as much documentation on the board as we can get away with, essentially. So to avoid having people dive into the user manual, or even worse, right? Not being able to find what they need, and you have to kind of jump back and forth. There we go, between the user manual and the board all the time.
Is this because you guys refuse to read instructions?
Yeah, obviously it stems from engineers feeling like you don't need to read an instruction to get started, obviously.
Yeah,
so it's
who needs instructions?
You can swap out the parts. It's hackable. You can plug and play. You can bypass. Use different drivers. I gotta ask, how thrilled was your boss or upper management when you said that you wanted to create a design that can basically just be plagiarized? Or is this the first that they're hearing about it? I don't know.
There has been convincing at multiple times that this is a good idea. So you got to balance these things, right? So our goal wasn't necessarily to try to just shove down, for example, Nexperia products or shove down Wurth Elektronik products. That's not our goal. Our goal is to try to make a nice development environment. And in our case, as Nexperia, we're quite known for having quite a strong service side of the company. So we're quite good at servicing our customers, and we're quite famous for this. I suspect with our interaction with Wurth Elektronik, it's the same over there as well. So our goal is rather to show our capability of servicing, right? Even through such a thing as evaluation boards. And we have to be realistic at the end of the day. Somebody will not necessarily use our MOSFETs. That happens, right? And that was my direct argument. We cannot force somebody to use our products. The best we can do is allow the evaluation of them to be done as easily, simply, and reliably as possible, while having a joy doing it and not diving through or trying to understand why is the motor not spinning. I know I keep saying why is the motor not spinning, but that's the most aggravating thing I had to do when that, as an application engineer, especially when I had a situation where the motor was spinning backwards, and it was not due to me flipping the cables the wrong way around. So I kept on flipping them around and redoing the phases, and it did nothing. It kept on going backwards, and it was the most aggravating activity I've ever done.
Well, I think like you said, it allows prospective customers to evaluate your product, but I think it does more than that. I think it shows a couple of things. It shows your guys' expertise in the area, and it also shows that you know what they're going through. To have done this development, I mean, you really have, kind of a understanding of what your customers are doing every day. So I think that customers realize that, and I think that they understand the value of that.
Well, that's a goal, right? So, let's, and this means, by the way, that we're not saying this is the solution. This is we're guaranteeing this is gonna solve everything and make you a sandwich by tomorrow morning at 8. But the goal is, if there is a problem, we would love to know about it. If there's something we've missed or something obvious that's not fitting your use case, that is actually something we would like to hear about, right? Preferably also discussing our products in between the mix, but if not, we still would like to hear it. So, because at the end of the day, the goal here is also simply to learn a little bit about what our customers and prospective customers are actually doing, not just throwing products at people. Not dismissing that approach either, just to be clear.
Yeah, and with the feedback, obviously, because the design and especially the software, the firmware is all open source. It's all on GitHub. So like, if anyone does find like any issues, then you can just create an issue or like basically report it, or you can even fix it yourself and push the code up back to us, and we'll update it, right? So that's the whole point of open source, right? So we all make that a bit better together.
And also, what else can you tell us about a deeper dive into the technical aspects of this design?
I'm going to the specifics of the different, for example, sensor options, right? So when we are sort of programming the board to run with different motors, you might have encoders, but also different types of encoders, right? You have absolute encoders. There's also incremental encoders and absolute encoders. Some of them use like different interfaces, such as SPI or I2C. We actually kept like pins available on the board that let you connect sensors like that as well. If you're talking about the, obviously we've got Hall effect sensors as well. You could actually have absolute Hall effect sensors, which is probably a bit more rare, but using I2C or SPI. So again, like you can use those. Back EMF option was also there. So all of those different things. I think when if you talk about the gate drivers on the board, we have everything operating at about 12 volts. I think oftentimes we get a question is that, oh, well, we don't run it at 12 volts. We want to run it at something else, right? Because I don't know, in your design, you might be running it at 10, you might be running it at 15. And that's pretty common. Maybe it's also a logic level device, and we don't actually the gate driver may not be compatible with that. That's why we actually recommend even propose alternatives. So let's say you want to have a logic level component, let's say your MOSFETs are logic level and you really need to drive it at a different voltage. We provide that, but also we provided a very wide range of operations. So I think 9 to 16 volts for gate drive as well. And again, you can just provide an auxiliary power supply for that. By default, it's 12. You don't have to touch anything. If you want to change things, that option's there. And current sensor wise, we did there were lots of different options where we could go down. I think there was some people might keep it very simple drive and just use inline a V-bus current sensor just to monitor the current, see how things are, how much current the motor is drawing overall, maybe not individually phase level. We've catered for that because we've just put in one of those current sensors. You might go a bit more complex going into FOCs, then great. We've got inline phase current sensors. Obviously, there's lots of different ways of doing that. I've seen a lot of people use high side current sensors, low side current sensors, and then inline current sensors with the motor as well. We used inline, which is a bit more complex, but it also captures if you are driving high side high side phase current sensors or low side. If you have any code that you already have that runs in any of those, inline works with both of them. So we went for the option that sort of works with all of them, basically, if that makes sense.
Yeah, I just want to take a step back. So you mentioned that there was for the full design, there was 3 boards. So just wondering what the core functions of each board was and what communication is taking place between them.
Yeah. Well, actually, we broke it into 3 boards based on that hackability aspect that Stein was referring to, right? So we wanted to, all of this could have been in one board. And what are the functional blocks here, right? We've got the microcontroller, and obviously that's controlling all of the logic stuff. So whether we've got fault LEDs as well, for example. So it's talking to all of those fault LEDs. You've got your motor inputs, the potentiometer to control the speed, gate drivers, a lot of things talking to the microcontroller. And then obviously the gate drivers then basically interfacing on the other side to the inverter where the actual motor is being driven. Now, we split those 3 into what sort of made sense to us, and that was basically the microcontroller board. So in this case, we supplied with the Leonardo board, and we did that because oftentimes, and I feel like that's something that's very different. You might be using a different microcontroller, right? And that changes everything, right? Because you'll have completely different. You might have completely different pinouts, or it's a completely different registers available to you. So the way you drive things might be very different, and that's a key thing that you might want to change. So obviously, microcontroller has its own different board. So that's board 1. Board 2, we've got the controller that actually, we're calling it the controller board, but actually that's basically connecting to the microcontroller board, and it has all of those logic stuff on it. So all the fault sensing stuff, the fault LEDs, the gate drivers. So we've packaged it into that side. So then again, it could be that oftentimes you might have your own gate driver, right? Because we're using a specific gate driver. whether you're going for maybe either end of the spectrum, right? You might be cost limited. You want to go for like a very low current gate driver, or you might want like a very high gate current drive, right? We chose something hopefully in the sweet spot, but like you might work on either ends, right? So you might want to change that. So that's why like we put the gate drivers on the second board as well, right? So you can potentially change that, put something else in between to interface, and then you've got that. And on the third side, we kept purely just the power stuff. So board 3, that's just your inverters. And obviously we had to have the current sensors and stuff on that side. We couldn't move that to the other side. And we kept the USB PD stuff on that side as well, because we kept all the power on that side of the board. That's how we sort of split it into those three boards.
Oh, that's amazing. It's also amazing that you're able to use a USB PD. Was that how difficult was that to implement, and what solution did you end up going with?
Well, I had to read up on the USB PD in the first place, right? All the two specifications, and I was like, huh, because I wasn't really aware of it. This wasn't really my field, USB PD. It was fun to start with. Obviously, I started off and I made like the first iteration of the board that had the USB PD, and this was my first time ever dealing with that. And obviously, I made some mistakes in there, and I had some pins swapped around. And if anyone's ever seen USB PD ICs, they're very small normally. Even the whether we're talking about the ESD components as well, like the diodes, they're very small to have very low capacitances, and everything's just very compact. And then I had to now to basically test the concept that it's actually working, right? Okay, let's say I didn't flip that trace, right? Is it still working? So I then decided to flip the traces using I can't remember what was the gauge of the actual cables, but yeah, a very tiny micro. I was working with microscopes and trying to solder in like all the traces and did all of that. I think I sent Stein one of the pictures and I was like, look at this. And then, yeah, I sort of got it working. So it was great proof of concept. Okay, everything was. I just made that one mistake. So cool, great. And then I tried to change something. And then because it's so delicate, everything sort of just moves around and then breaks the whole thing again. And I'm like, okay, great. Here we go again.
I am pretty confident I saw when I visited Anas in the lab once, because he was telling me. I'm pretty confident I saw some tears in Anas's eyes at one point with that USB PD. Just to make that public knowledge now. So
yeah. Yeah, because I had I don't know why that's happened.
So here we go. See, so we had some ups and there were definitely some downs, right?
I was just going to ask if they were tears of joy or tears of frustration, but we know we got it.
Yeah,
I
think they were both.
Yeah, tears for every emotion.
Yeah, exactly. Yeah, so we went through all of them.
But yeah, USB PD was interesting to start learning, doing. Learned a lot of things with the different stuff. I was quite surprised to obviously know that you can actually do up to 240 watts right now with USB PD. Quite crazy. But yeah, we've done it up to 100 watts, which is I think the most commonly available power capability out in the market. So we didn't want to overspec it more than that. I don't think anyone's got a hold of in their house a 240 watt USB PD charger. I don't think none of your laptops are charging that fast. If yours is, I'd like to know what laptop that is.
If they do, nobody's talking.
Yeah.
Yeah.
Yeah. So I said another question for you too. It looks like this comes preloaded with whatever software is needed to control. It's a trapezoidal control of a brushless DC motor that probably has Hall effect sensors or some sort of a. But it looked like there was some possibilities for some sensorless operations. So maybe tell me about that. Would it even be possible to use this to control an induction motor?
Well, for the first thing, for the firmware bit, yeah, we obviously for this we provided with just the trapezoidal one to begin with. That's what's on the GitHub. We're looking to expand to do all of the other drive methodologies as well, but we provide all the information for you to be able to do that as well. In terms of the sensorless, we've basically verified all of that with we've checked the zero crossing back EMF sensing and stuff. So it's really not a major change as well to do that, because typically if you're running it on like microcontrollers, sometimes you don't have like that many ADCs to like, maybe you'll have to like monitor a few things at the time, and then you have to swap around things. Because we have like dedicated circuitry, it's very easy. So you just basically turn on your interrupts on the microcontroller, and then it's pretty similar to the censored code at that point, because you just have to offset your phase angles a little bit to make it just basically work with the sensorless mode. Inductor motor stuff, I don't see any potential issue if you were to run it. I haven't run it obviously with an induction motor, but it's all there to be able to run it. I don't see anything that's missing. I guess we'll have to maybe plug one in and find out.
Sounds like fun.
So you mentioned going through so many revisions to add different struggle points for the customers. How many revisions has this gone through, and what features have you added along the way?
I actually remember how many revisions that was. I think the absolute beginning was a completely different board at that point. Like this was before I think we were just Stein and I were talking about that evaluation kit stuff. We didn't really think about all of the different pain points yet. At that point, it was just basically two boards at that point, and it didn't have like much of the extra flexibility at that point. It was just sort of just purely brushless DC at this stage, and that was just the starting point. Obviously, we didn't have any inline current sense at that point. We didn't have the back EMF sensing at that point. We only had the high side current sense, and you could use like different sensors. Like I think you could have used Hall effect sensors and the sort of encoders and stuff, but that was pretty much it, right? You couldn't do FOC, you couldn't do like back EMF sense, like all the sensorless drive, but that was like, I think through the iterations, we got the feedback that, okay, we need that. And then we added, I think, back EMF sensing on one of them, validated that. And then I think after that, we added the inline current sense for the FOC and the PD on another iteration. I think overall, there was probably like 4 or 5 iterations, but most of them were like, most of the major changes were just between 1 or 2, like maybe 2 or 3 iterations. The other ones in between were probably like me twisting the traces where they were not supposed to be. Stuff happens.
How do you think that feeds into our future collaboration, and how did you feel the collaboration between Wurth Elektronik and Nexperia, and how do you think does it impact or feed into the future collaboration in terms of future projects, as we are intending, of course, to have a long-term sustainable collaboration between both our companies?
Well, if nothing else, the rumors I've heard, seen in other email chains forwarded to me, is that clearly some of our labs are starting to adopt Wurth Elektronik components in their labs outright. So it's just going to be present for our apps engineers on our side. We also would love to do more. So because we're in a similar boat, right? So because you don't necessarily control the brains of the design, which is the microcontroller. So you're designed in together with other products. We do not have the brains of the board either, which is the microcontroller. We're also designed in together. So we're quite similar in our requirements, although you guys are passives, we are on discrete semiconductors. But our requirements and our problem that we're trying to solve in terms of getting to potential customers, getting to potential users is very similar. So what makes me quite happy, at least in this partnership, and that we will also continue with it, is our strong focus on trying to solve the problem with the user and trying to make the service side as nice as possible. We also have that now with Wurth Elektronik. Exactly.
Also, regarding the purchasing, because obviously there's so many things that we had to purchase to go into this board. I think one of the easiest thing to order was obviously the components here, because I think I was just like, I wrote an email, just wanted to ask, oh, can you guys ship me, like all the components for this? And there was like a large number of components. And then I expected obviously a long back and forth, obviously communication to get that done, as with most of the suppliers that I had to deal with. This was like just a response saying order has been placed. I was like, whoa, that was that was fast. So that was quite nice.
Roughly, how many components were you talking here? That, I mean, were you expecting to get just a few in a nice box at your desk, or did it ship to your home and you have to put everything into the garage?
Actually, I wish I had the picture of that. It's actually not one of our colleagues who's been helping us with a lot of this shipments. It's Kane, and I don't think any longer can work at his desk. Because it's just filled with Wurth components, Wurth electronic components now. Like, I think he actually sent a picture of it to us.
Little do you know, we're actually moving our warehouse to Kane's desk.
At this point, I'm sure that's the case.
One final question. How can a customer go about and getting their own design kit?
So there are multiple ways, but the easiest one is get yourself onto Nexperia.com, write out motor driver kit, and that's the easiest way. And then, depending on how early you are, either reserve the kit or just order it outright. So we're going to try to make it available with disties as well on our webpage. We're going to try to make it as available and as wide as possible.
Thank you for joining us for today's podcast with Nexperia and Wurth Elektronik. This wraps up part 2 of our 2-part series, and we are grateful to the experts from Nexperia and Wurth Elektronik for taking the time to chat with us about the new evaluation kit and how it can benefit our customers. In this episode, we covered the kit's technical aspects, including its open sourcing capabilities, remote access features, various uses, and we also had a brief Q&A session with our experts. The kit is now available to order. You can see the board in person and in action at PCIM Europe 2025 from May 6th through the 8th in Nuremberg, Germany, or you can order your own. Click the link associated with this podcast or visit Nexperia online for more information. For related components and more technical details, visit Wurth Elektronik online. We understand that not all images and links are available on all streaming platforms. To find the complete video and more information on this episode, visit us at www.we-online.com/podcast or check out the Wurth Elektronik Group YouTube page. You're listening to Wurth Elektronik's What's Up Radio podcast, where each week we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Wurth Elektronik technical specialists. we're going to shine a light on interesting topics, such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Wurth Elektronik's What's Up podcast.